So what if I told you that the moon doesn't just cause tides to Earth's oceans, but also causes tides to Earth's crust itself? These are called Earth tides or crustal tides, and depending on where you are on the Earth, this can be as extreme of a shift as 55 centimeters or 22 inches. And if that seems like a lot, just remember that the Earth is really big, so if you actually calculate it as a percentage, it's only about 0.000009% of the Earth's radius. Humans have known about ocean tides pretty much forever because we can actually observe that directly and it affects our everyday lives. Crustal tides, on the other hand, are a lot more difficult to measure because if the entire ground is moving up or down with you, you don't really have a reference point to measure against. This is also complicated by the fact that the Earth's spin also causes bulges, and the Earth and the Moon are not really aligned in terms of the lunar orbit. So it's not something that's ever really relevant unless you're in a very specific niche field in which you need to know the exact shape of the Earth at any given moment. And you might be saying, well, why doesn't this cause huge earthquakes all the time? Well, the thing is, earthquakes are a shift in fault lines on a local scale, which sometimes can be seen on the surface as physical shifts in the ground. But when the entire Earth is shifting on a much larger scale, that's not something that can really be felt. And then I hear you ask, if the moon's gravity is strong enough to pull on Earth's crust, then why isn't the moon pulling on me? This is one thing that people often get wrong about gravity. See, gravity is a two-way force. The moon only pulls on you as much as you pull on the moon. And since the mass of Earth's crust and Earth's oceans is a lot greater than your mass, then the moon is going to affect those a lot more than it's going to affect you. So anyway, enjoy your very literal ups and downs today.